So I'm going to start with a little example data set here. This data set comes with the ggplot2 package, so you can always just load it up after you install the packages, after you install the package. And so this is the MPG data set. It looks at miles per gallon for a variety of different types of cars. And you can see that in this data set from the STIR that I did that there's 234 observations, so there's 234 different types of cars, and there are 11 variables that are measured. In particular, I'm going to be looking at the displacement variable, which is an indicator of how large the engine is. So this is the DISPL variable. We're looking at the number of cylinders and we're going to look at the highway mileage, so the HWY variable, and then we're going to look at the DRV variable, which is what kind of drive it is. Is it a four-wheel drive, a front-wheel drive, or rear-wheel drive? So notice how the factors here are labeled appropriately. So, for example, the manufacturer variable is labeled by the manufacturer of the car, Audi, Chevrolet, etc. And then the DRV variable, which indicates the type, the drive, is indicated with the 4 for four-wheel drive, F for front wheel, and R for rear wheel. So a very simple plot you can make, I call this the hello world for ggplot, is to call the qplot function. On the x-axis I had this displacement variable, which is the kind of engine size variable. And then on the y-axis I got the highway mileage. And you can see that I specify the data frame with the data argument. So I say data equals MPG, so the data come from this MPG data frame. And so that's very simple. You can see that the plot that it makes looks very different from the traditional base plot. You can see that there's kind of a gray background and there's white grid lines behind it. The points are closed solid circles rather than the kind of the typical open circles from the base plotting system. And then there are labels on the x and the y-axis. One of the things we can do is modify some of the aesthetics, so we can highlight different subgroups of the data. So one of the subgroups can be determined by, so there's lots of different cars here. Some of them are front-wheel drive, some of them are rear-wheel drive, and some of them are four-wheel drive. So we can separate those observations out by looking at the DRV, the drive variable. And so I've specified the x and y coordinates just like before. I specify the data frame just like before. And then another argument I have is the color variable. And I'm going to say that the color is mapped to this drive variable, DRV. And all that says is that the different levels of the drive variable will be each assigned a different color. And notice I don't specify what those colors are. They're specified automatically. So you can see on this new plot here that the front-wheel drive cars are in green, the rear-wheel drive cars are in blue, and the four-wheel drive cars are in red. And so you can see that the front-wheel drives tend to have the highest mileage, the four-wheel drive tends to have the lowest mileage, and the rear-wheel drive is something in the middle. And notice that the legend was placed on the plot automatically, and the color coding the different levels of the factor variable. I didn't have to do anything special, and so it's very nicely kind of organized and thought out, and you don't have to do anything. Everything's done automatically. Another thing that you sometimes want to add is a statistic. So a statistic is just some summary of the data. And so the summary that we've chosen to add here is a kind of smoother, or the more technical name is called low-S. And it smooths the data, so you can see the kind of overall trend in the data set. And you can see that I do this by adding the geom argument. And the geoms that I want to put on this plot there's two types. One is I want to add the points themselves so I can see the data. And then I want to add a smooth geom. And the smooth is this blue line that goes across, and the 95% confidence intervals for that line are indicated by the gray kind of zone. You can make a histogram with the qplot function by only specifying a single variable. So here I only specify the highway variable, and it shows me the highway mileage for all the cars in the data set. But then again, I like to kind of separate out which cars are four-wheel drive, which cars are front-wheel drive, etc. So I specify, instead of the color argument, I specify the fill argument, which says that the different elements of the histogram are going to be filled with different colors based on what drive they are. So here you can see a similar picture that you saw before, which is that the four-wheel drive vehicles tend to have the lowest mileage, and the front-wheel drive tend to have the highest mileage. Another feature of ggplot is called facets, and the facets are like panels in Lattice. The idea is that you can create separate plots, which indicate, again, subsets of your data indicated by a factor variable, and you can make a panel of plots to look at separate subsets together. So one option would be to say to color code the subsets according to different colors, like we did before. But if you have a lot of data points, that can be tricky to look at, and then all the colors might overlap, and it may be difficult to see the separate groups. So an easier way to do that is to say split out the three groups into separate panels and make three separate plots. So that's what we've done here. On the left side here, I've got three different scatter plots of the displacement versus the highway mileage, and then I've split it out by the different drives, so four-wheel drive, front and rear. And so you can see the relationship for these three subgroups, and it's just a different way to look at the data rather than, say, color coding the three groups. And I specify this with the facets variable. So I can, and the facets variable takes a format that's basically, there's a variable on the left-hand side and a variable on the right-hand side, and they're separated by a tilde. And so the variable on the right-hand side determines the columns of the panels, and the variable on the left-hand side indicates the rows of this kind of matrix here. Now notice that in the left plot, which is outlined by the red box, there's only one row. And so there's no variable that indicates how many rows there should be in this plot. And so that's why in the facets argument I have a dot on the left-hand side. On the right-hand side, I've got the DRV variable, which indicates that that should indicate how many columns. And now because there are three levels to this DRV variable, there are going to be three columns. And so since there's only one row, there's going to be three plots all in a row like that. On the right-hand side in this plot that's outlined with the blue box, I've got three histograms. And notice that I put the DRV variable on the left-hand side of the facets argument now, so that indicates I want three separate rows. But because there's nothing on the right-hand side of the tilde, I have no column. So I just have the one column, no extra columns. So I just have the one column for the three plots. And now I've got the three histograms. You can see you can look at the highway mileage divided up by the three groups.